Here we have a question. In this question, we have to determine the coordinates of point B so that the water strikes. Here, as we can see, we are giving an angle of 60 degree and an initial speed of 15 feet per second to the water jet. So here, as we can see, as the water sprinkles out, we know that the only force that will act on the water is the force of gravitation, and that will act in downward direction. So here we can write the acceleration in downward direction as g, which is equal to 9.8 meter per second square, which is acceleration due to gravity of earth. So here, as we know, along x direction there's no air resistance present. So we can say that along x direction, as no force is present, we can write the equation of motion along x direction, where we can write Sx will be equal to Vx into time t, where Vx is the velocity, initial velocity in x direction, which would be equal to 15 feet per second into cos 60 degree, which will be constant throughout the motion along x direction. But as we know, as the force is being applied along vertical direction, the speed along vertical direction will change, where we can write the speed along vertical direction as v dash y is equal to vy plus a into t, where t is the time, a is the acceleration along vertical direction, vy is the initial velocity along vertical direction, and v dash y is the final velocity at point B along vertical direction. So here we can write the displacement equation along x direction, as you can see here, and let's write the equation of displacement along vertical direction, where we can write it as sy equal to ut plus half at square. So here t is the time that is required, u is the initial velocity, which will be equal to 15 feet per second into sine 60 degree, and a is acceleration due to gravity, which is the equal to g, which is 9.8 meter per second square, but it's in downward direction, so we'll consider it as negative. So here we are also given the path equation. So from here we can write the value of y in terms of x that is given to us. So here we have three equations and we have two unknowns. So from here we can calculate the value of x and y coordinates and also the value of time t. So first of all, let's move forward. Let's write the equation of path which is given to us, which is y equal to 0.05 into x square. So here, as we can see, acceleration due to gravity in feet per second is given to us, which is minus 32.2 feet per second square. As we know, the acceleration due to gravity in meter per second is minus 9.81 meter per second square. So here we will convert this meter per second square into feet per second square, and it will come out to be minus 32.2 feet per second square. Now the initial velocity va is given to us, which is 15 feet per second. As you can see, in this direction it is given to us, which is 15 feet per second. Now let's divide this velocity in two parts, along vertical direction and along horizontal direction. Horizontal component would be equal to Vx cos theta, or we can write it as V cos theta, and the vertical component would be equal to V sin theta. As you can see, this is the value of Vx and this is the value of Vy. So first, let's write the displacement along x-axis, means along horizontal direction, which is equal to Sx equal to S naught x, which is the initial displacement, plus Vax into t. So as we know, Vax is the value of Vx, which is equal to Va into cos 60 degree. Now let's write the value of distance along y direction, which will be equal to Vy equal to V naught y plus Vay. This is the y component of velocity plus half a t square. So from here, first of all, let's write Sx, as we are given the value of S naught x and S naught y as 0. So from here, we can write the values of Sx as x and Sy as y, where we have to calculate the coordinates of point B. So first of all, as we can see, the x component of velocity is Va cos theta and the y component of velocity is Va sin theta. So let's substitute the value of theta. So from here, we can write the value of Va, that comes out to be, Vax comes out to be 7.5 feet per second. And the value of Vay, that comes out to be 12.99 feet per second. Now let's substitute the value of x. So here we can write x equal to 7.5 t. So from here we can rewrite the equation as t equal to say x divided by 7.5. Now let's substitute the value of t in equation number 3. Let's substitute the value of v naught y as 12.99 feet per second, as you can see here. So from here we can write the value of y, that comes out to be 12.99 t plus half of minus of 32.2 into t square. So now let's substitute the value of y as 0.05 x square, as we are given the path equation. So from here we can write the value of x in a quadratic equation form, that comes out to be 0.05 x square is equal to 1.732x minus 0.286 x square. So from here we can calculate the value of x, that comes out to be 0 and 5.15 feet. So as we know, at x equal to 0 the points are same. So from here we can write the value of x as 5.15 feet. So for that, let's substitute the value of x in this path equation and find the value of y, that comes out to be 1.33 feet. So from here we can say that the x coordinate of point B is 5.15, while the y coordinate is 1.33 feet. Thank you.